Okay, so our first equation, when we plug in that x value, we're going to have a times 1 squared plus b times 1 for x plus c equals 7 for y. And if we fit in the rest of our equations here, let's do that now. I'll use a different color. We'll have a times our x value, which is going to be 2 squared, plus b times our x value, which is 2, plus c, and that equals 2. The third equation will be a times 3 squared plus b times 3 plus c, and that gives us a y value of 1. Lastly, we're going to have a times a 4 squared plus b times 4 plus c, and that equals our output of 3. So if we go over here to our matrix that we get, for the coefficients that live on A, we've got 1 squared, 2 squared, 3 squared, and 4 squared. Notice that this first column is our vector x squared. For the next column, the coefficients that live on the B are just 1, 2, 3, 4. And notice that that column is just our column for x. The coefficients that live on the C, we've just got one C in each of the cases, so that's a column of 1s. Write that there, kind of small. That's a bunch of 1s. And this is going to be equal, or actually multiplied, times our vector A, B, C, and then that is equal to our constant. Let me see if I can move this over, make a little bit more space for us. There we go. That is going to be equal to our constants, which are 7, 2, 1, 3, and that is our column vector for y. Okay, so we have a very good setup here. I'm just going to outline this before I get to MATLAB. So for matrix A really looks like, in the first column, it looks like x squared, right? The next column is just x. The third column is a bunch of 1s. We know what is vector v. That's our ABC. And that is all equal to our big column for y. Okay, with that setup in mind, we're ready to go to MATLAB, and we will solve for v by computing P inverse of A times y, and that's going to give us the coefficients A, B, C that fit our parabola, that fit our quadratic model to the data. Okay, so we're over here in MATLAB. Let's enter our column vector for x. X was 1, 2, 3, 4. And our column vector for y looked like 7, 2, 1, 3. Now we want matrix A to be set up with 4 rows and 3 columns. Now in the first column of A, so all rows, first column, we want x squared to live in there. And notice that if you just try to do x squared, you will get an error. And the reason that you'll get an error is that vector x, this is a 4 by 1 vector, and you can't multiply a 4 by 1 vector times another 4 by 1 vector. And indeed, we don't want to do matrix multiplication here. We're just trying to square each component. So the command that you do want to use here, it has a dot caret. What that little dot does is it tells you we're just going to square the elements component wise. Okay, and that's exactly what we did. In the second column, we just want vector x. And in the third column, we want a bunch of 1s. We want 4 rows, 1 column worth of 1s. So there's matrix A. Vector v will be the pseudo inverse of A times vector y. Okay, and I'm just going to pull out the values that are of interest. We will say little a equals the first item in V, little b equals the second item in vector V, and little c equals the third item. Okay, let's do a scatter plot. So there's our data. I'm going to do a mesh grid, and we talked a little bit about this in the previous video. Okay, and now we're going to hold on to our scatter plot and we're going to do a line plot. So how does this work? We have our mesh points. For the y coordinates, we want to do a times the mesh point data squared plus b times x mesh points plus c. And that did a really good job.